Welcome back. This is Nick Agram. I will be discussing from this video and succeeding videos. I will be discussing a lot of theorems, and I will be basing my discussion on the book Circle Geometry for high school students, and it is written by Jarrett Stolz. So Jarrett named the first that I'm going to discuss here Theorem 1, and it is called a line from the center to a chord. As you can see here, a line from the center to a chord. What's that mean? That it means that I have a line from the center of the circle, to a chord. We have chord here. According to Theorem A1, if a line is drawn from the center of a circle perpendicular to a chord, it is perpendicular. That means it is 90 degrees. Then it bisects the chord. That means if I will name this A and this B, and this is, let's say this is F, that means AF is equal to BF. They are equal. How, according to Theorem A1, how can we prove that they are really equal? Then what we can do is we can do a line here. Maybe I have another, and have a line here connecting. If this is O, then we can say that we have two triangles. If this is a 90 degree and this is 90 degrees, then we can say that the OF is equal to OF. They share the same side. And OA, the line OA is equal to the line OB. And both are 90 degrees. So we have, if we call this as, how can X maybe, and X there. I will call it X sub 1 and X sub 2. So the angle X sub 1 is equal to angle X sub 2. Both are 90 degrees. And the proof or test of congruency says that we have OF, so side, both are equal, and then OA is equal to OB, hypotenuse, hypotenuse, and then we have 90 degrees, both of them 90 degrees. That means we're dealing with right triangles here. Right triangle says that if we can find hypotenuse that are equal to both triangles, and we can find a side that is equal to both triangles, then we have a congruent triangles. That means AF now is equal to BF according to test of congruency. Of triangles. Now we have we have written a proof for Theorem A1A. The other way around, Theorem AB, if a line is drawn from the center of a circle to the midpoint of a chord, then the line is perpendicular to the chord. So midpoint, now we have a midpoint there. And midpoint is always always give us the idea that AF, or the two lines, or a line, is divided into two equal parts. Let's do some examples. Let's see here. Number 1. I'm going to say it again. These examples come, or these problems come from the book Circle Geometry. Calculate the value of P if O is the center of the circle. So the value of P here, you see that EC is equal to 40, then it should be ED is equal to P, which is equal to ED is equal to EC. Why? Because it says in Theorem 1. So we have ED is equal to 40 millimeter. Let's do number 2. Calculate the value of Q if O is the center of the circle. As you can see, H is 60. Millimeter. That means FG is equal to 30 millimeter according to and GH according to Theorem 1 is 30 millimeter. We're going to solve for Q. So if I'm going to have radius here now, so OH is equal to Q. OA, the line OA, the distance between O and A. By Pythagorean theorem, it says that we have OH squared is equal to 40 squared plus 30 squared. Then we have OH squared is equal to 1600 plus 900. And we have OH squared is equal to 2500. Then we have 50. OH. By taking the square root of both sides, then OH is equal to 50 millimeter. Let's try the next. If this is my center, okay, calculate the value of R if the radius of the circle is 5 centimeter. So radius, I have radius there, I have radius there. Let's take another color. Then I have another radius there, another radius there. So if I can find this, and if I can find this length, then I can already find R. So if we call this O, so we have, because this is 8 centimeter, so this is 4 centimeter. I'm going to call this X, and this is 5 centimeter. By Pythagorean theorem, we have 5 squared is equal to x squared plus 4 squared. Then we have 25 is equal to x squared plus 16. If we subtract both sides of the equation by 16, then we have x squared is equal to 9. Taking the square root of both sides of the equation, then we have x is equal to 3. That is 3. I'm going to find y. The whole this one. I will call it y. So y. Another color. Y. This is 3 because this is 6, the whole. JK is 6. And then still my radius is 5. So I have, according to Pythagoras' theorem, 25 is equal to y squared plus 3 squared. Then I have y squared plus 9, and then we have 25 minus 9 to both sides of the equation. This is 0. I forgot to say that that is 0. Then we have y squared is equal to 16. Taking square root of both sides of the equation, we have y is equal to 4. So that r is equal to y minus x. So we have r is equal to 4 minus 3. So r is equal to 1 centimeter. I forgot that centimeter, that centimeter. My next video, I will be calculating some more. There are more examples there. I hope you will stick around. See you there.